Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back working on the Jimmy Diresta bandsaw restoration, and we're working on the lower shaft that will drive the bandsaw wheel. So this will be the main shaft that will have the drive pulley on one side and then the main bandsaw wheel on the other side that will rotate everything around. And we're having to make a new one because when we removed the old shaft from the bandsaw, we messed it up. We basically had to bore it out of the hole because it was stuck so bad. So we're making a new one. Now, I've already started on this project, and you can go back and look at previous videos if you want to catch up. But we've already turned a taper in here, which will actually go into a tapered hub on that bottom bandsaw wheel. The next step is on the end of this, there is a threaded area there where a nut goes up on that tightens everything together. But this is a little bit special thread. It is a left-hand thread rather than a normal right-hand thread. So instead of righty-tighty, when you turn it right, it's going to loosen it off instead. And this has to do with the rotation of the wheel and the rotation of that bolt, so that when the wheel is actually turning, it's actually tightening that nut. The inertia in that nut will tighten it rather than loosen it. It's one of the problems you often have, and one of the reasons you often see left-hand threads is because if things are turning in the direction that unscrews the nut, over time you can actually loosen the nut and create a big problem. So that's the reason they use left-hand threads. Now this, I'll show you here in just a minute. We've already got it turned down to the diameter. It's 1.25 inches in diameter, and it's going to be 10 threads per inch, and it's going to be left-hand threads. Now I thought what I would do today is kind of go over how to set a machine up to do left-hand threading. Now we've talked about right-hand threading many times, single point threading on the lathe, and left-hand threading is almost the same, but you have to do a few things a little bit differently because obviously you're going to be turning it in the opposite direction that you normally do. So we're just going to go through the setup of the lathe, come over here and actually turn this left-hand thread. All right, so first off, we just said 10 threads per inch. So we need to set our lathe up so that it's turning 10 threads per inch. I'm going to show you on this Monarch Model K. It's got a quick change gearbox where you can change either the feed or the threading, the pitch that you wanted to use. So we're going to show you setting it up for 10 threads per inch. I've got you zoomed in kind of down here on the quick change gearbox on this lathe, which is this kind of area down here. Now I will say that a lot of your real old lathes didn't have a quick change gearbox. They actually had change gears. You had to actually take individual gears and you had to go to a chart and figure out your pitch you wanted to cut, and you'd have to change the gears out over here manually to get the right ratio. So basically what this is doing is as the chuck makes one revolution, it's moving the feed a certain amount, and you can we basically got two options. You either got the threads or feeds, and there's two different rods in here. One is for like when you're cutting metal, that's your feed rate, and then when you're cutting threads, that's your thread pitch. And on this chart down here, there's two numbers. There's a number on the top and there's a number on the bottom. And for example, on this 10, we got 10 threads per inch is on the top, or it's 0.0104, which that's your feed rate. So for every revolution of the chuck, when it's in this one, it's going to move 10.4 thousandths of an inch. Okay, so like I said, your more modern machines usually had the quick change gearbox where you could just go down here and manually change this without having to change gears. Basically, you have a rack of all the gears inside of this that you would have to manually change out, and you can just select the one you want by moving this tumbler around. A lot of lathes too, sometimes they would have an economy version, particularly like for a home shop or whatever, that might be the manual change gears, and then you could also get the quick change gearbox. It costs a little bit extra money. So anyway, some of you guys may have to do this a little bit differently. Now I've already found the 10 on here, which is this one right here, and basically what I want to do is you can just pull the slider out and you get it lined up into the one you want. And what this is doing is it's actually, there's like I said, a whole like a Christmas tree of gears up in here, and I'm selecting the gear that I'm pulling onto. So we got it in the one for 10, and then I come over here and I read it says AE, and these are some more chain selectors. So we have a range selection here for AB, and this is CDE. I want to make it go on AE. So again, you got a selection. I got it on A. And then this one up here, you got CDE, so I got 3 different options that's in the E option. This one here, this selects between either whether I want to use feeds or threads. Again, there's 2 different rods that come out of this that power it, and this is determining which one's on. I've got it over in the one for threads right now. And then the other thing I have to do, because this is left-hand threads that I'm cutting, instead of my cutter moving in toward the chuck, I need for my cutter to move away from the chuck so that the chuck is turning and it needs to move away. That's this selector on this lathe, so I know that when it's up in this one, it's in the normal mode where the feed or the threads are cutting toward the chuck. When I move it out here, it moves away from the chuck. So we've got it set up for 10 threads per inch, and we will confirm that on our first cut just to make sure, because I have made mistakes and come over here and thought I had it in the right slot, and things not just be quite right. So just as habit, my first cut is just a scratch pass to make sure, to confirm that I got everything set up properly so I don't cut the wrong threads. Okay, there you go. There's your selector box. Next, we come down to the apron, the saddle of the lathe, and the compound. This is called the compound up here. So on a metal lathe, you've got 2 different areas that feed in and out. This one here goes straight in and out, and then you can also rotate this up here, and you can move your cutter in and out up here if you want to cut an angle. So and they call this a compound because you can select which angle you want to do. You just loosen up the bolts, move this thing around, there's a scale on there, and you set it for whatever angle you want to do. Now when cutting threads, your thread point comes in at a 60-degree included angle, so that means 60 degrees total from one end to the other. And when you think of an included angle, what you need to do is you need to look, okay, if we're moving straight in and out, it's half of that. So you make that a right angle, and that's half, so 30 degrees. So you want to set your compound to half of the included angle of whatever one you're cutting. So for normal threads, a 60-degree thread, you want to set it to 30 degrees. Now, actually, if you read the books, it'll tell you 29.5 degrees is the proper angle, and that's what I always set mine to. And you often hear debate as to whether it needs to be set on 29.5 or 30 degrees. I'll be honest with you, it probably doesn't matter that much, but the machinist that taught me 29.5 degrees. That's what I've always used. Again, a lot of your old books and stuff will tell you 29.5 degrees. So I've got this compound set to 29.5 degrees. Now the other thing you have to remember is when you're cutting threads, you use the in and out. Basically, you always go back to a 0. You go back to the same spot. You'll set a 0 on your dial, and you will go back to the same spot, and you feed in using the compound going in at that angle. Normally, when you're cutting towards the headstock for right-hand threads or normal threads, you would have the compound turn out in this direction because you're cutting on the front leading edge of that, and you want to move your cutter in the direction that you're going to be doing. Because we're cutting left-hand threads, we're going to be cutting away. So instead of having my compound set in this angle, I've got it set in this angle, and that's very important for doing left-hand threads. A couple other things. I like to put a dial indicator up here on here, and when I move my cutter in and out, I can kind of just verify that I'm going back to where I was on the last cut. But then too, this will tell me how far my cutter is actually moving in. Because you're moving in at an angle instead of going straight in, if I move this, say 5 thousandths on the dial, in fact, I'm just going to do that. I'll tell you what, we'll do 10 thousandths to kind of amplify it. But I'm at 80, I'm going to go to 90. I'll tell you what, let me get the backlash out of that. We'll do it again. I'm going to do 90 or 10 thousandths on here. But it only moved 6 thousandths. Why is that? Because we're doing it on the hypotenuse of a triangle, okay? So for every thousandths that you move in, it's not actually moving 1 thousandths in. So this gives me an accurate measurement on how deep my cut is rather than just reading it right off the dial. And I like to just have that as a visual indicator. And you can look up in your machinery's handbook, and for whatever thread pitch you're cutting, it'll tell you how far you need to go from where you start all the way in. And I usually look that up, and it kind of gives me a reference as to, okay, how far do I need to cut in? And usually once I get close, I'll start either measuring it with a thread micrometer or just testing the fit, which is usually what I do. I'm just going for a good fit. So if I got the nut, I'll just run it up on there and test it. But anyway, I like using that dial indicator up here. The other thing I'll mention, I mentioned this before, when you're single point threading, when you come out of your cut, you've got your cutters actually cutting in there. You will have to back it off to go back in there, or to either get it out or to put it in, and then you go back to 0 on your dial, and you're back to where you were before. One of the really cool features that Monarch lathes have in them, and I'm sure there's probably some other manufacturers that do too, but it's not on most lathes, is there's a little set screw here on the side. And when you tighten this up, there's a stop inside of this that actually stops it on 0. My dial is set to 0 right there. And when I come out, I really don't have to pay real close attention to the dial. I just go to a hard stop and I'm back at 0. Really nice feature for doing single point threads. And like I said, not all lathes have that option. The Monarch lathes, which this one does. And that's one of the reasons why I like a Monarch lathe. One of the many reasons, but that's one of the really cool features. Okay, I think we've kind of gone over the basics. Let's get in here and cut some left-hand threads. So one of the nice things about cutting left-hand threads is that usually because of the direction you're cutting, you're moving away from where your thread starts. You actually start the thread kind of at the bottom end rather than turning to the bottom end. What's nice about this, like with regular threads, you're coming in and you have to manually stop that cutter. In this case, we're coming up against the shoulder. If I don't stop it in just the right place, I crash my cutter. I can mess up my work, I can mess up my cutter, and it's just kind of nerve-wracking, particularly to someone that hasn't done a whole lot of threading, on being able to stop that thing right where you need for it to go. With left-hand threads, we're actually going away from our work, so we can kind of manually come in here, start our thread down here in the bottom, and when it cuts, it's moving away, and we're kind of going into empty space down here. We've got a big area to stop. So in some ways, cutting left-hand threads is a little less nerve-wracking than cutting regular right-hand threads. All right, so what I'm going to do is we're going to come in here up against this shoulder, and I'm going to start things up. And what I want to do is I want to move my cutter in using the compound until it kind of touches off, and it just starts making a real light cut. And I call this a scratch pass. I just want to make a real light cut on that first cut. And what I'm going to do is we're just going to engage the half nut here in just a minute. We're going to move it out, and I'm going to check my thread pitch to make sure that we're cutting the right pitch. So let's let a number come around on the dial. We'll engage. We'll let that come out. All right, we'll stop. And let me go grab a thread pitch gauge right here. These little thread pitch gauges. I got all these leaves in here. I want to find 10 threads per inch, which is what we're doing. And this is just a standard that we can check what's going on. And I'll look on there, the tops of my cuts, match the bottoms of the cuts. I'm on 10 threads per inch. Again, verify. I always verify before I start. And that's kind of my 0 point that we're going to cut down to. So it's kind of off screen, but I zero my dial indicator because that's my starting point. Now I'm going to back off on the straight in and out. We'll come back in and start my lathe up, and we'll go back to 0. And that is basically, I'm back where I started from. And we'll make another pass. I'm just gonna dial in. We'll just dial in about 10 thou on this first cut. Again, I'm gonna wait on my number to come around on the dial, engage, and we make a cut. There we go. And this is kind of a rinse and repeat operation. We're just gonna keep doing that one pass at a time, just a little bit at a time until we cut all the way down. I'm gonna go look up in my machinery's handbook how deep we need to cut for 10 threads, and that way I'll know on my dial indicator how far I need to go. Be right back. All right, give you a little bit different view of what's going on so you can kind of see everything that's happening here. We're ready to make our next cut. First thing I'm going to do is I'm going to put a little cutting oil on this. It just kind of helps things go a little bit better, particularly when you go in there deep. Now we've already we need to come out of our cut that we just made, so I'm going to pull everything back, because if I drag my cutter back across right now, we're going to actually cut into that, which we don't want to do. So again, we'll come in here. I'm going to go back down there to about as far deep as I can go, and we'll just come to my stop right there. Now we're going to feed in, and again, I'm looking at my depth gauge here on my dial indicator. I looked it up. We need to go a total of 65 thousandths in. I'm going to do about another 10 thousandths pass here. I usually start out kind of heavy, and as we get in, we'll take lighter passes. Now what we got to do is we're going to be looking at this thread dial down here. We have to engage our half nut to pull this thing out at the exact right point. And we're looking at these numbers coming around here, and I'm going to wait for one of the numbers to line up on there, and we will engage the half nut. Yep, I missed it. Sometimes you don't get it just right. There we go. And we cut across, and then we'll stop. All right, so you can kind of see what's going on. Again, now we'll come out, back into the shoulder, go back to 0, and we'll dial in my next cut, which will do about 5 thousandths this time. Wait for my dial to come around, and I missed it again. Wait for another to come around. There we go. All right, let's rinse and repeat. Waiting on my number. Here's a close-up of the thread dial. Notice we got 4 numbers on here. Now for an even thread pitch, I can engage on any one of those numbers. If I'm doing an odd thread pitch, it has to either be even numbers or odd numbers, one or the other, just pick one. But I usually just stick to even numbers, that way I don't ever have to worry about trying to remember. So here comes a 2. We engage, and then when we get out, you'll see it start spinning again. That just helps us get right where we need to be. All right, continuing on here. Here comes a 4. Here comes a 2. As I get deeper into this cut, now let me show you what's going on here. We're actually cutting on this leading edge, and when I move my cutter in, I'm actually cutting on that whole edge. Some people want to go straight in. When you do, you're actually cutting at the beginning and all the way through, kind of on both sides of that V. By moving it in at the angle that you're cutting, you're doing 100% of your cut on the back side there. I'm actually moving in at the same angle on this side, which in my opinion is the right way to do it. As you get deeper in though, you're making a wider cut. So you can see there, it's a pretty good sized chip coming off. I'm only feeding in, I started out at 10 thousandths cut. As I get deeper in here, my cut gets smaller and smaller on how much I feed in because my chip is getting wider and wider. I'm down to doing about a 2 or 3 thousandths in feed as we go. So just kind of talking things through. We'll go back down to the bottom here, feed in. I'm going to dial in about 3 thousandths on my dial indicator and get ready to make our next pass. There we go. Another way you can kind of tell when you're to your depth is, notice right now we kind of got a flat across the top. That should become a fairly sharp point when you get to your final depth. And we'll start making some measurements here in a little bit to actually see where we're at. All right, 3 thousandths depth of cut. Wait for a number to come around on the dial and make our next pass. So check this. This is a thread micrometer, and it's like a regular micrometer that it measures, but you need to look. There's a little pad down here that has like a thread tooth in it, and then you have a 60-degree V up here. Now this one is for measuring a range between 8 and 13 teeth per inch. They have different micrometers for different size ranges, and this is also a 1 to 2 inch. So this is the one I need for this particular thread, 1.25 inch diameter, 10 threads per inch. Now what I'm going to do is we're going to come in here and we're going to, let me kind of get this out where you can see it. We're going to put that V on this side right on the top of one, and then directly across it we're going to measure in between the lap there and just kind of check and see what the depth is. And there's a feel here to get this just right, and I'm going to pull it out and check and see what that measures. And we are at 1 inch 125 75 plus 7, 182. Now I measured over on my other shaft that I have, and I'm kind of using, this is a non-standard thread. This is not a thread you can look up in the book because it's a oddball thread, but that's what we're dealing with. Now my other shaft for the top, it's got the same thread, but it's a right-hand thread, but the depth should be the same. And I'm going to use that for reference because I don't have a nut that I can check a fit on, so I want to get it just right. Now the other one measured 1 inch of 157 thousandths. So basically I've got 25 thousandths more that I need to take out of this. But keep in mind that that's total. And when we're cutting on a lathe, we're cutting on one side, but it is in essence also removing the material on the other side. So my depth that I need to move in is going to be half of that. So 25 thousandths, what's that? That's going to be 12.5 thousandths we need to still move in. I know where I'm at on my dial indicator, and I can see, we don't have a sharp point on there like we should, so that tells me I'm not quite deep enough. And now, because I have this thread micrometer and I can compare to the other one, I know how much deeper I need to go. So we need to go another 12.5 thousandths. I'll cut a few more out. We'll make another measurement, kind of sneak up on that final measurement. So, all right, let's finish this thing up. So you can see I'm at 65. I want to go to 70. I'm going to probably go to 75 and take another measurement. Again, we'll back off. We'll come in. We'll go back to our 0. I'm kind of cutting on the back side of that groove, which is fine, a little bit closer than I was before. All right, there's my bottom. I'm going to feed in a couple of thou on the dial indicator here. We'll wait for our number to come around and let her cut out. All right, let's get in here with our thread micrometer again. And see where we're at. Should be real close. All right, it looks like we're within about 1 thou or 2 of our final measurement, which I think is going to be fine for what we're doing here. I am going to turn the nut to fit this thread. So, I mean, you know, this is just going to get me kind of in the ballpark, but I think we're where we need to be. So we're going to basically quit threading. I do want to clean up the bottom of this groove down here a little bit. On the other one, it's just kind of machined out square in the bottom. So you got room for that nut because we can't really thread all the way up to this shoulder. We're just going to machine a little area out in there, and that way if that bolt comes in past this edge, it doesn't run up and tighten up before it hits the shoulder. So I'm going to put a parting tool in there to do that. But I think we've got our depth of cut where we need for it to be. All right, parting tool in here. We're going to come right up to this shoulder and just kind of cut that out down there in the bottom. Again, that will allow that bolt to go right up to that shoulder. We want to get down below the root, the bottom of the thread. I think we got it there, and then I'm going to kind of come forward a little bit as well and just kind of clean up that area, make it look a little bit nicer, and that'll be real good for that bolt, or the nut rather, to have some clearance down there in the bottom. I think we're about done. Final thing I'm going to do is I will usually just take a little emery cloth and hit the tops of these threads. That just kind of makes it where it's not super sharp and kind of removes some burrs up there and gives a little clearance down in the bottom of that hole. And I'm also kind of hit that leading edge there just to make sure I don't have any sharp burrs that will cut you if you're not careful. There we go. Our thread is done. Well, there we go, an exercise in cutting left-hand threads on the metal lathe. Hope you enjoyed that and got to see it a little bit. I get a lot of people asking about single point threading. I do it a lot on the lathe. I don't always go into all the details. I have done it several times on videos in the past. I don't think I've done one on left-hand threads. Maybe, I can't remember, but here we go. We got one now. So there we go. The last step on this shaft is we need to turn the final diameter from here on out. I need to go do some measurements and figure out what that is. I know we got to take a little bit off of this, but we're just about done with this shaft and having it ready to go back over on the bandsaw. There you go, guys. That'll be a wrap. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are greatly appreciated. Helps a lot with the analytics on the channel and getting my videos recognized in the YouTube algorithms. So very big help if you do that. Hit that bell icon up there to get notifications when new videos are posted to the site here. And with that, we'll catch you on the next video. Again, thanks for watching.